good morning, good afternoon, good evening at whatever time you're looking at this video or at whatever time you're viewing this video. In this video, we are basically going to talk about 20 important object-oriented questions and answers. So what we have done is that we have taken up 20 questions which are most discussed or which are more controversial, kind of questions, which have been discussed or which are discussed again and again between developers or between senior people about object-oriented programming, and we are going to take these questions and we're going to answer those questions here. Now let's talk about whom this video is basically targeted for. This video is basically targeted, first thing, it is majorly targeted for freshers, freshers who are very much new, who want to understand object-oriented principles, who have queries like, what is abstraction, what is encapsulation, what's the difference between abstraction and encapsulation, when should I use an interface, when should I use abstract class, etc. So it is very much targeted for the freshers. That's the first thing. Second, said and done that, it's also very much useful for the senior people, because normally as a senior person, if you're working in a project, what happens is that you have probably 10 or 15 years of experience. You are either a project manager or you're either an architect or whatever it is. You get completely so engrossed in your project that sometimes you tend to forget the basics from where you come from. So this video is also targeted for seniors who want to do a quick revision and who also want to understand that what are the new kind of features provided by C# or .NET from object-oriented programming perspective. So let's enjoy these 20 questions and let's try to understand object-oriented principles in a much better manner. So let's start with the first question. What's the problem with functional programming? Now there are four basic problems with functional programming: reusability, extensibility, simplicity, and maintainability. So let's try to understand the first problem, that is reusability. Now here's a simple screen I have. This screen is basically a product screen which basically takes in a per product cost. So if let's say that you can put a number of products here, and then you also put in that how much product you have bought. So for example, you have bought 10 products and each of the product costs 10 rupees or $10. So you can say 10 into 10 becomes your total cost, that is $100. So in other words, the functionality here is that it's more of a product order screen, where basically you put in the quantity, you put in the cost, and you get the total cost of this whole order. Now this is a single entry screen. In other words, I can put in one product, I can put in one order, and I can calculate the cost. Now there is the other view of the screen which is more of a grid view. So here if I want, I can do multiple entries. Now both of these screens do the same thing. The only difference is that this is more of a multiple grid and this is more of a single grid. So in other words, the logic is absolutely same. Now let's look at the logic, what we have written. So you can see over here that I have a simple function here. This function basically takes in per product cost, it takes in a quantity, and it multiplies the per product cost with a quantity. Now this function I want to reuse in the other screen also, but I can't. So what I do is that I do a copy paste, and the same function I have copy pasted here. So both of these screens have two different copies of the same code. So we have increased our redundancy. So over here we have the calculate cost, which basically helps us to do the which helps us to calculate the total cost, and then again in the second screen, which is a different view altogether, but the logic is same, even there also we have the calculate cost. So in other words, the same function, we have two copies of it. So just concluding what we are talking about, both of the screen, even though they use the same logic to calculate cost, we have different copies of the code in both the UI. So what has happened is that we have increased redundancy. In other words, we have decreased reusability. So we are not actually reusing the code, but we are more of like we are copy pasting the code. Now many of the developers who are into COBOL and C would say that, in C we also had something called as the include function. So in include function, what I can do is that I can make a common file called as common.h, and I can include that file again and again wherever I want to reuse those common functions. I agree to that, but remember that those includes are more of a physical include. It is not a logical include. In other words, it is not decoupled. So when you actually include that common.h, it actually makes the file size bigger. Okay, so the reuse, even though there was a workaround of doing reusability where people were doing includes, but still it was not exactly reusability. When I say reusability, in terms of that, it's a complete different component, or it's complete different logical unit altogether, and I just refer that logical include. I don't try to include that logical unit into my entity. For example, over here in these screens, right, in these two screens, I will not try to include that code. I will rather refer that code. So the first problem is reusability. The same functions or the same logic is copy pasted in different sections, like over here it was different UIs again and again. Now the second serious issue about functional programming was extensibility. For example, we have a calculate cost function here, and this basically, as we have already discussed, this calculate cost function basically gives us the total cost by multiplying the per product cost into the quantity. Now let's say that we want to create a new extensible function from this, which will basically take into discounts. So if you want to do that, there is no way we can take this function and extend it or like inherit it. So what we do is that we create a complete new function altogether called as calculate cost with interest, and then we pass in the discount value and we do the calculation. So in other words, we again have to copy paste that code into a new function, create a new function, and then add new logic to it. So again we have a redundant code. There is no way we can take up a current function and extend it. So the other problem with functional programming was extensibility. So let's summarize. We talked about the limited reusability provided by functional programming. Then we talked about absolutely no features provided in terms of extensibility. And because of these two issues, right, we land up in a very complicated code. So in other words, we land up with a very cluttered code which is scattered across projects, various files, and that becomes very difficult to maintain. So overall we end up with reusability, extensibility, simplicity, and maintainability issues. So these are the four important problems which are related to functional programming. Now let me just talk about the maintainability thing, because that's an important part or an interesting part, which we need to understand. Now whenever we talk about software projects, right, it's very important to understand that you will get more return of investment if your software project runs for a longer time. For example, let's say that you make up an accounting application. Now if your accounting application runs for 1 year, and then after that you say, you know what, this accounting application is not able to adapt, it is not able to extend, I cannot really reuse it, so you scrap that project and make a new one. But let's say that you make that accounting application proper with high reusability, high extensibility, so you can run that accounting application for more 6 years, and with this your return of investment is much better. So at the end, if you do not do proper object-oriented programming, or if you do not implement object-oriented programming properly in your project, it really hurts your finance at the end of the day. So that's a very important aspect to understand. So summing up together, the four big problems associated with functional programming is reusability, extensibility, simplicity, and maintainability. And we discussed all about this in our previous section of the video. In the coming video, we will see that what are the four important characteristics of object-oriented programming, and how we can basically use them in projects, or how we can basically implement them in C#.